Okay, so in this particular problem, we have a nutrition lab that tests 40 reduced sodium hot dogs. So I know my N is going to be 40, and finds the mean sodium content is 310, and that's the mean of these 40. So the mean is equal to 310 milligrams of sodium, and the population's standard deviation is going to be 36. So name and calculate a 90% confidence interval. Well, I know that I'm going to do a one sample Z interval. It's Z because it's a normal, because I know the actual standard deviation, and it's a one sample because I am only dealing with one groups of 40. It's not like one kind of hot dog and another kind of hot dog. So one sample Z interval. So then I can just go to my calculator, and if I go to stat, test, I'm going to do a Z interval number 7, and I have data, and my mean, or my standard deviation, sorry, I don't have data, I have stats. My standard deviation is 36, the mean I'm told is 310, my N is 40, and my confidence level is going to be 90%. And so there is my confidence interval, 300.64, 319.36, which is approximately to three significant figures, 301 to 319. And I like to do the actual one that you get the full one and then round to three significant figures, and it takes care of the significant figure issue. So then it says, why is this interval so wide? Well, it's 18 milligrams. How can it be made narrower? So if I want to make it narrower, that means I want to do something where I want it to be like 307 to, let's say, 312, something, or 313, something like this, so it's a narrow interval. Well, in order to do it, I want to try and make my standard deviation smaller. And the way I can do that is by increasing N. I want N to be larger. Okay. I feel that's not a full explanation. It's going to come also with C part. State with a reason whether or not the central limit theorem was used in this example. And the answer is yes, the CLT was used. Because we actually took, so we imagine you have a great big giant sample, or this is the population of all our hot dogs. And from this population, I take a group of 40 of them, and I find the average. Now, this is one group of 40 of a magical theoretical sampling distribution. Here is here's a sampling distribution, or here is 310, and so this is a sample from the sampling distribution. The standard deviation here is going to be the standard deviation over the square root of N. That's the one that's being used. And I am allowed to use the central limit theorem because N is larger than 30. And since N is larger than 30, I can use the CLT, and it makes a normal distribution. And so my normal of the sampling distribution is the norm of all the means, or the random variable of all the means is a normal with a mean of 310 and a standard deviation of 36 divided by the square root of 40. So if I want to make this narrower interval, I increase N, which decreases the entire standard deviation, which takes this curve here and it squeezes all the values in tighter. And so then you can find a confidence interval that is smaller.